Right, hi guys. Yeah, I'm just trying to get this live streaming set up. I was just doing something. I was going to try and catch people before they disappeared. But my stream health doesn't seem to be great right now. Hopefully I have audio. Yes, I do. Great. That's something. Let's try and get it a bit better. Okay. My streaming's not doing very well. My internet connection's not behaving particularly well today, it would seem. Let's see if I can improve the speed a little bit. Let's reduce my bit rate a little bit, I'm afraid. Slightly lower quality. I'll be doing a little update on the Leakage tester project. How's it going, Oliver? Olivia, sorry. Get it right. Let's try to get the streaming a little bit better behaved. Cool. Yeah, just my stream health was showing as being a bit poor, so it's dropping some frames. It dropped quite a few. So I'm hoping that now I've tweaked it slightly, it'll be a little bit better. This time of day is not actually the best time to do streaming. It's my internet connection starts slowing down about now until later in the evening. Actually gets quite bad then. So actually, when I'm doing uploads to the YouTube, I actually do them in the morning if I can, because it goes 10 times faster. So normally I try and do live streams a bit earlier on if I'm doing them, but I just thought, I'll do a live stream. What the hell? Let's do this. Here we go. Hello. That's a bit better than that. So looking at the desk. Well, hopefully better. I don't know. It might be worse. Depends on your perspective. Okay, so 4 people watching so far. That's not too bad, I suppose, considering there's no advanced warning, and it's not the best time of day. At least, well, it depends on what country you're in, I suppose, but generally it's not the best time of day for me at this time of day. Okay. So, I suppose let's try and drag this thing around a bit and get some extra screens running, I suppose. Hold on. I'm not particularly well prepared. This is a bit of an impulse. Thought I'd do a live stream and share what I'm doing at the moment, where my project is currently sitting at, and what ideas I have, and to get some feedback on it if anyone's interested in that project. Okay, let's try and get this a bit better. I need to split this out to another window. That one? That one? No, hold on. I've got to get the right link. Is that? I'm not organised. That's the right one. Okay. Move to new window. Drop this up here. Right. Sorry about this. I should have got all this prepared beforehand, but I was trying to get the stream started as early as I could. Trying to. Drop this back down here. Hold on. Yeah, I hate being unprepared for things like this. It's not very good. Yeah. What am I trying to do? Can't see what I'm doing. There we go, that one. That's what I want. Okay. So, go back to YouTube's tab. Get the right tab, be helpful. Where are we? That one. Okay. Now I'm kind of set up. Sorry about that. Just about there. Could get the video camera controller set up as well. And I need to be able to see the top chat too. Where are we? Pop out chat. That's what I want. So I'll keep the chat going. Okay. I think we're there. Right, so what I'm basically doing here is just, as you can see on my desk, which is a bit messy, but I've got this project on the go, which is the high voltage leakage tester. Right, so as you can see, I've got it basically built. I've got, as you would have seen, I did the part 6 video, published that this morning, and well, this morning for me, about 12 hours ago, something like 8 hours ago, and so that's at the point now. So, it works. I've got it built up, and there's more footage which I've got to record yet and just cover things properly. But I've got to the point where it's actually built and working. But I'm just trying to refine the design a bit, and I've actually come to a bit of a choice there, where I've got the designed version with the PCB, which I've got a couple of errors on, which are easily fixed. There's only minor errors. I've already redesigned a PCB. I'll publish a redesign one when I do that, when I actually finish the project, then I'll make that available. And so I've got the design version, which I'm now running on 220 volts going to the board, into the PCB, rather than 115, which I wanted. It can do 115, then go through 2 upper stages, but the current handling is not as good. It can't handle as much current. So I think really comes down to the capacitors I've chosen. I don't have the best capacitors. I should have gone to a larger value. So I'm actually going to look at buying some more capacitors and chucking those in. So right now I'm going through 220 volts going in. It's actually going through, I've got a 240 volt transformer input on the primary, but it comes out as about 110 per winding. So I've got 2 windings in series, so that's about 220 volts or so going into the PCB. And which is then being doubled, right? So I'm getting about 440 volts out of it, which is probably fine anyway. But I've come to the conclusion that although this works, and this is probably quite an accessible way of doing it for everyone to actually build it up this way, without requiring anything particularly specialised, there's an easier and cheaper way of doing it. Now I'm going to show you this in a second. And basically what the current design is a big transformer which costs about $40 in New Zealand or so. It might be cheaper in your country, I don't know. But it's about, what's that, about 30 US, something like it works out as, roughly, I don't know. So that's that big transformer that's on the left there in the top corner. And then I've got the smaller transformer, which is about, I think it's about $8 or something in New Zealand. It was fairly cheap. And that's a little 12 volt power supply in the top right corner of that box. And then I've got the capacitors as well, which also, they're about $20 worth of capacitors there to do the voltage doubler. So you add all that up, you're approaching $100 in Zealand. So you think, well, that's a bit expensive. It could be done a different way. Now this way it works, and it's accessible. It's something which everyone should be able to obtain. But the better way is to actually use a high voltage boost converter, which is what's sitting on the desk there. I've got a couple there. I've actually got 3 there. 2 of them are the same. I just happen to have 2 sitting there for some reason, and they are fairly cheap. That's about $10 New Zealand for one of those. So it's about $7 US or so, roundabouts, depending where you go. I've got a link on the last video I published this morning. I put links there to that boost converter on Banggood, so you can go and get it from there. I'm an affiliate link on there, so I actually get a credit on my account and points and stuff by you purchasing through there, and you don't pay any extra. I just get benefits for referring you to them. And so those are cheap, so for basically less than the cost of the capacitors alone and the voltage doubler, you can use a high voltage boost converter. But it relies on you being able to get a high voltage boost converter, all right? And that's what I don't like about it. So they're currently easily available. You can get them readily, right? Banggood's got them, AliExpress has them as well, and they are fine. Okay, so they're currently easy to get, but there's different versions, and as I've got on the bench here, I've got a smaller one there too, which I'll point out and go to in a second. I'm going to go to the bench side of things, and the smaller one can only produce a couple of milliamps. Right? It's not very powerful at all. With high voltage, you can do it like 1,000 volts, but only does a couple of milliamps, which isn't really good enough for this project. So the larger unit can do, I think it's rated at 200 milliamps at 45 volts, but as the voltage increases, then the current drops off, obviously. So, but at the maximum voltage, which is 290 volts, it can do 50 milliamps. You know, fine, it's alright, it can do it. But so it can provide plenty of current, which is the other thing I'm looking at, is that it can actually give a better outcome as well. So not only is it cheaper, it gives you more current, which is better for doing charging big capacitors and stuff like that if you're doing a big capacitor tester. So yeah, I'm kind of on a fence right now. I mean, do I carry on with what I've already designed and built, which is easier for everybody else to obtain, or do I just do one of these high voltage modules, which is cheaper for everyone else to obtain, but who knows how long you can get those boost converters for? You know, they're available now. Are they still going to be available in 6 months? Who knows? So it did cross my mind I should buy a bunch of them and just, you know, keep a stock and say if someone wants one, I'll sell them one. You know, but I'm not a salesperson. I'm not a reseller. Right? It's not something I do. So it's you know, it's a bit of a gamble there which way I go. So I'm kind of tempted to just carry on where I am right now with the existing design, and then change it later on to the boost converter. That way, it's one can make a choice in which way they want to do it. It's probably the better way. I think the boost converter is the better way to go, but it depends on people getting them. Right, so let's just pull this back up again. I've waffled on and off for now. Like, I haven't really shown you anything yet. Oh, where's my Windows gone? It's disappeared. Get her back. Okay. My stream dropped off. That's no good, is it? My stream's dropping off. Okay, let's just fix this output a bit more. Hold on. I'm going to reduce the speed some more, I'm afraid. My stream is showing as being really bad. Let's I'll close the web browser, can I? No. Right. Hopefully it's still going. Yeah. Sorry about that. So, right. Let's go to the bench. And let's just close this camera off. Desk. Wide view. Here we go. I'll spin this around a bit so you can hear me a bit better. Okay, so here's the modules. Now this is just the loose one I've got sitting around. Now, this is the actual unit here. There's different versions of this exact board. This one's actually a dual rail supply, so it's got a negative supply here and a positive supply here. Okay, I'll get a bit closer. Hope we can focus on that. Okay, here we go. And it's got a DC input. Now it's rated as 8 to 32 volts, but I found 11 volts is where it kind of started working. So I wouldn't go below 11 volts. If you're going to use this, I'd say use 12 volts. That's my recommendation. Okay. There's adjustment there which goes from say 45 to 390 volts. The more voltage you can put into it, the more it can produce as well. So that's another consideration. You want to produce high currents, just put a bit more voltage in. You can do up to 32 volts max. I've run up to 31. That's as high as my power supply goes. Well, unless I put it in series mode. Right, now these ones, actually, when I got this and this one, they're both already damaged. They've been squashed in the post, and the capacitors were ruined. So I've had to replace 4 caps because they were squashed. Let's try and find a bad one. There you go. There's the worst one there. So you can see that. See how squashed that is? Absolutely munted. So these 4 caps are shorted out. So when I first went to go and use them, I thought, that's not right. And yeah, so I had to repair them first. Bit of a pain, but yeah, well. Anyway, so these are my preferred module, and it's got a nice little heatsink on the back there, and you can call that, or you can even change the heatsink to a bigger one if you wanted, I suppose, or mount that onto a chassis and screw onto it, so the screws are transferring heat through onto the chassis, or fan cool it, or something like that. So you got lots of options with that one. This one here is much lower current. I think it was cheap. I think it's about $3 something from memory, but it can do like 1,000 volts. But if you need just a high voltage without much power behind it, then this might be what you want. But it's no good for this project. I tried it and it just can't do it. The current draw on it, just kills it completely, just drives the voltage right down. But yeah, that's a nice little unit too if you're wanting something that does that, but it's not suitable for this. Okay, stream is still going, cool. Right, so where I'm up to with this, if I unplug this, you have to ignore this messy wiring I've got just here, because that's just, I'm using it as an adapter. I've only got one wire coming out, so there's the ground wire there. Let's untangle it a little bit. Right, just going to the chassis. These grounds are actually linked. Right, so it's actually the same terminal effectively. It's just watch out for that if you ever use one of these. And that's the positive wire coming out there. So all I was actually doing there is on here I've got a little jumper block. Let's unplug this and move it around a bit so you can see. Alright, so there's a little jumper pin there. And that's 4 pin. And the idea of that is that it allowed me to choose which capacitor bank I was using, you know, for the multiplier stages. So, you know, if I was using 230 volt or whatever, I'd only need one stage, so I could just choose the first stage. The second stage would be too high voltage. So that's why I put that in there as well, to allow flexibility for whoever goes to build it. They can choose which option they want to use it on. And over here is that clamping Zener diode there, so it clamps the supply to limit the voltage possible. Alright, now, I say this transformer, and this little circuit board I made to make a DC supply for the Arduino, and that voltage doubler there, or multiplier section, that is a lot of effort compared to buying one of these things. Alright, now the benefit of using this is that it can run off 12 volts. The Arduino can run off 12 volts. What that means is that I've got a little voltage regulator on there, which it can run up to like 30 volts or something as well. So that's actually the same sort of supply range as this will take. Okay, so they actually marry up very well. And using one of these modules to me is preferable, because you don't need that capacitor section, you don't need to get this big heavy expensive transformer, you don't need to mess around building this little 12 volt power supply just to run the Arduino. You don't need to mess around with any of that. You could just use this board. Right, you can shove that in there, run it off a decent 12 volt supply. You want a couple of amps, right? So it can provide about 2 amps at least, to give you plenty of leeway there for surges and stuff like that. And you can run the whole thing off 12 volts, dead easy. Now the other option is that, because I've already got a mains connector on the back there, an IEC connector, is you can get like a DIN rail mount power supply or something similar. This is 12 volt, 3.5 amps. Right, so this is completely adequate for this job. I could probably actually shoehorn that in there and get it to fit. Okay, so if I do change this design, I can probably squeeze it in. Then unfortunately I'll be able to put the IC connector. If I'd moved it a little bit further over, I would have got this in easily. But it's close to actually, maybe it will or won't fit. I don't know yet. It's a bit close. So it's likely I'll end up changing this design here and just putting this inside with this. Alright, or could just run at 12 volts. So those are the options. So I'm actually sort of looking for feedback really as well about what people think I should do with this. You know, should I just carry on with this design, or should I just focus on this and simplifying it? Because that does greatly simplify it. But as I said, it does rely on being able to get this board. Okay, I suppose I could do some demonstrations of the unit. I mean, no, yeah, you would have seen the front panel in the last video. So there you go, there's the front panel. I'll pair it up a minute actually and show you it. So how's the stream going? Still good? Cool. Let's just have a look at this. I'm just hoping that it's going to carry on behaving. It's not the best time of day for streaming. Oh, I've got 7 people watching now. Awesome. Coming along. Alright, so now the thing with this project is that it is high voltages, so it is rather dangerous. You know, that's the concern. You know, it is a dangerous piece of gear if you touch the wrong thing or you forget what you're doing. Yeah, so over here's a little jumper plug, and I'll hook this up and I'll demonstrate it, shall we? Let's do this. I'll use the internal power supply first, and I shall hook up a capacitor with some test leads somehow, which I've used for this. Hold on, let's get this set up. this stuff out of the way, give myself some space to work. There we go. Power. I'm actually running this through a variac as well because I was trying different supply voltages to see how it behaves. I think I need more height than that so you can see this front. Yeah. Is that going to do it? Maybe. Right, let's get the capacitor hooked up. It's... where did I put it? No, here it is. I'm blind. Now. There's also options for this front panel switch. Right now I've got it as a momentary switch, so you only push that down to do the test. And let's power this up. Hopefully you can see the display. Might be big enough. It's not the best angle still want more really. Let's try this. That's not going to stay put, is it? No, it's not. Let's try and get this right so you can see the bloody thing. Can you read that? Probably can. I can read it on the screen, so hopefully it's right. So as you can see right now, it's set at 386 volts off the internal power supply. Okay, and that little adjustment on there, which I'm turning, we're going to drop it right down. So this is a multi-turn pot, which I actually find a bit annoying. I did actually try using this pot here, which is a single turn. It's a big high wattage one, but it's 47k, and it was getting quite hot because it's across the supply rail. So one side's negative, one side goes to the 400 volt rail, right? So it worked, but it got warm, and that's a bit concerning. So this pot I've got in there now is 100k, so it's not as bad. They're both high wattage pots, but so you can go right down to 0 on this, you know. I think the lightest it actually go to is about 4 or something like that. On the very first bit, there you go, 1 volt, and just get it. Alright, so let's wind this up. This is a, what's this cat? 450 volt cat. So I can go all the way up on this. So I'll just do that. I'll show it back up again. So maximum voltage, and let's do a test. You see the voltage of the cat charging up, you see the current as it's charging. Right, so you can see the unit is working, it functions, and it will come to an equilibrium there. The accuracy of the voltmeter readings, I'm still tweaking that. It's something you have to tune because it depends on the voltage of the divider. So it's got a resistor divider in there, which is because you obviously can't shove 400 volts into an Arduino, you just blow the crap out of it. So I've got a big voltage divider in there, and you have to tune the resistor values in the software on the the firmware on the Arduino. I keep calling it software, it's firmware, isn't it? So you tune it in the Arduino code, and then you can basically calibrate the voltmeters, but they're not super accurate because it's only as accurate as the ADC in the Arduino, and that's not 100%. And it also seems to be skewed as well. Right, so, and when you release that switch, it stops supplying power. I've got a resistor on the back of the switch, so that then drains the capacitor. The option for this switch is that you can actually have a 3-position switch, maybe like a momentary one as well. I've actually got one, so I know you can get them. So you can have center off, which is like idle, up could be drain, down could be test. Right, so I'll do the test and then drain it. And you see the LED there, it went off as it went below 32 volts. I'm actually going to change the code slide to make that flash, to make it more obvious. So when you're out of potentially dangerous voltage, it flashes. And just make sure you don't touch things. Well, hopefully it makes you brings it to your attention. You shouldn't be touching things which could kill you, or at least hurt you. Hi SCI, how's it going? Yeah, so that's the project as it stands. You know, as you can see, it is a working unit. The prototype works, but it's just that issue with which version do I use? You know, so that works like that. Actually, I should show the charge current again. Let's do that again. Right. So if you look at the charging current, which I'll get a bit closer so you can see, and then I'll do that initial test and hopefully, right, and get it to stay in focus. Now watch that charging current on the initial startup. So that's 15 milliamps it started at. Okay, that's sort of the peak of what this circuit can do. it can't do much more than that in this configuration. If you're going through 2 doubler stages, it's even less than that. It's only about 7 or 8 milliamps at most. So it doesn't do as well, so it takes a long time to charge up a capacity, you know. Just wait for it to drop down so I can touch things. Now, I will turn it off, and that is still going to be live there. So I have to be a bit careful. Just untangle my leads on here, because these caps are still going to be charged, I suspect. Let's see if it's drained yet to make sure before I touch anything. Yeah, it seems it's drained it then. Yeah, all good. Now I can touch things. Be really careful, like I said. Now I'm going to unplug this and plug in this high voltage board here. Now the beauty of this is that you can actually do this because the pins are isolated, so those 2 pins are the caps under the voltage multiplier, the bottom 2 pins are the common, so you can just plug this into the common and use an alternative supply. So this is, you know, this could even be an upgrade you do later on, you know, possibly if you need more current, for example. Now let's go into the chassis. And now I need a supply, which I need some more clip leads for. Hold on. Is that them? Nope, that's not clip leads. Where are they? Got to find the right leads. They're hanging in the wrong space, so I can't find them. Okay. I can't use that one, that's not going to work. Okay, because I need to run this off a supply. Let's just run this over there. I'm not keeping a close eye on the chat, so if there's a delay answering you, if anyone asks any questions, that's why. I'm just glancing over occasionally when I think of it. And that ain't going to work. Let's find a different one. Is that what I'm looking for? Yes, it is. Right, now I found it. Okay, that's what I got. So let's just set these up correctly so it's not going to be a problem. Right. Turn it on, turn it on. Now that supply there should be generating quite a bit of power. 250 volts it's doing right now. Okay. So don't forget it's limited, and when you put a load on it, it does drop. That's what I want, this thing here. And I'll be careful what I touch, don't lose that myself. Especially when it's live, that'd be really bad. Pretty hard to edit that out. It was the first time I did it out, getting zapped anyway. God, a mess of wires. So this can produce more current, and let's find my little screwdriver. Where's the other one? Gone. I don't know, I've lost it somewhere. Let's try and get this stuff away. Let's make sure it's turned right up. There you go, 364, that's the most we can do. So the voltage is a bit lower overall, which is a bit of a trade-off in this case, but yeah, but what I can show you here is that it's dual rail supply, which could be handy, because what happens then, let's get it across there, get it on there, come on, it's not going to demonstrate, is it? No, because I'm on AC, that'd be why. DC, that makes much more sense. Okay, 800 volts. Right, so rail to rail, 800 volts. That's got some interesting potential there if you can figure out a way of wiring some wire that's sitting to here without sharing the ground. You know, that's also another option. Okay, let's get that out of the way. So I'll do exactly the same test again, and Let's pick this up here so you can see it. Try not to touch anything that's high voltage. And do exactly the same thing again. You see that? The current was much higher, so it charged much more quickly, and that's the benefit of it. You know? Upgrading the value of these capacitors that are in there will help it. So I've currently got this with 1 UF capacitors in it, so 1 microfarad. And if I've actually got the ones I took out because you know it's not using these at the moment. I took those out and strapped those on the back to make it 2 UF, and it did a lot better. It was much closer to what this board can do. So upgrading those caps to sort of, you know, maybe 4 UF would be an idea. That might just solve the problem and still be okay, but it still has the issue with that design being more expensive than using this in that state. You know? Let's get this before it shorts out. Okay. Alright, so that's where it's at. I'll do it again. That's 34 milliamps I saw then. Alright, so I think 35 is the most I've actually designed it to handle anyway. So this basically maxes out what this can do. Remember, right, on the shunt resistor value, which I've got installed in there. So it's 150 ohm resistor in there, and so that's part of the limiting factor about what you can actually read, because you can only do up to 5 volts offset. Right, so that shunt resistor cannot go above 5 volts, otherwise it'll get clamped by a Zener diode, which is 5.1 volt. Because the Arduino can only go up to 5 volts anyway, so that's what it will read, is up to that voltage. So yeah, that's the project. So rather than trying to record all that and edit it out and mess around and trying to convey that, and you know, it takes a lot of time to edit videos. I'm trying to get my videos to be a bit more concise. I'm trying to take out a bit of the waffle and stuff like that, and shorten them a little bit and try and get them to be a tighter time frame. Hopefully that shows up. You probably haven't noticed because you haven't seen what's before. Like, quite often I might be stripping out 10 minutes of a half-hour video. You know, what you see in half an hour was probably recorded in 45 minutes or so. Like 1 hour videos might take 15-20 minutes off one of those. So hopefully it's helping a little bit. Okay, so that's that. Let's turn this down. I'll shut it off before I forget and touch something. But these caps hold their charge for quite a long while, especially as these two here, currently right now, have got no load on them. So they're just going to sit there powered, and they'll still be live in a day's time. So I have to make sure I discharge those before touching them. Yeah, I'll just leave that for a little while. Let it drain down a little bit by itself. So the revised board I'm doing is very similar to this one. It's just got a few little tweaks on it. Like what I've had to do. Let's get that away. Start make it so I can move everything around again. Bit crap running around there. Right, get it out. So there's a resistor standing up on the board just there. Now that's supposed to be laying down the board in the original design. What it was is I added on the dual sensing, so I could sense not only the supply but also the device under test. Because I added that extra sensing point on, I forgot to allow for that for the switching. Right. So what I've had to do now is break into that line for that resistor, because that's the main supply that goes to the device under test, right? And that's just like a buffer resistor, so it doesn't overcharge too quickly. It's a current limiter in case it's like a dead short or something like that. And also allows you that difference between the supply voltage and the device under test voltage. You can see how quickly it's charging, that sort of stuff, instead of just shoving full current in and hoping for the best without blowing things up. Anyway, so I had to break into that line there. So the new version has got that already done. So I've got some terminals on the board to run the wires to instead. And what I've actually done is for the switch, I've got 3 terminals on the board for the switch. So the switch wires go to the board rather than doing this wiring up on the back there, just to simplify that. And there was something else. Oh yes, there's a mistake on this board here. I'll show you on this blank one. I don't know how the hell I missed it, but these diodes here in series, well, if you look this side, there's no track. If you look that side, there's no track. So they're supposed to be linked together. So it's only a little error. So it's really easy to fix. You just bridge across the back of the board and it's done. Okay, so on the new revision, obviously, I've fixed that as well. And I've changed the layout around here a little bit and just tidied this up, moved things around, and I've added the drain resistor as well. So the resistance on the back of the switch right now to drain that capacitor out, it's now on this board as well. So that's all just wire straight to the board, and you don't have to worry about it too much. It just simplifies things quite a bit. Yeah, so that's where that is. It's only a small revision on the board, but you know, it's just stuff I've done to this one. The other little interesting thing I found is that when I was probing for voltage on here, occasionally the display would just blank. It would just disappear, like it got corrupted or something. You know, it got confused, got some corrupt serial data or something like that. So what I had to do is I put some ferrite beads on. Right, these big ferrite on the input to the display, so the power supply line and the serial line, because I'm using a SparkFun serial display. I'll just put one around that, wrap around that a couple of times because it would. And I've also got one here on the output wiring, so the wiring goes to the switch, which has got the supplies for the capacitor. I've got one just shoved around there too because there's space to do it. And that's fixed that problem. I don't have any issues now with that display blanking. So it must have been some kind of noise being generated, which is just radiating right through the thing and confusing the display. That fixed that straight away. Since I did that, it was sorted out. Because also I did it occasionally when I was using this thing for the first time, the high current. When I first did a test, and it started charging the cap, and that high current, it would trip it then sometimes as well, almost every time. You know, if I drop the voltage down a little bit to reduce the capacitance, reduce the current, then it'd be okay. It's like literally like 20 volts difference. It'd do it or not. So that seemed to sort it out. I haven't had any problems since I did that. So yeah, I'm actually likely to say, you know, use this module here rather than this arrangement. You know, this is what I designed because I thought that'd be a nice simple way of doing it. But you know, it's simple, but this is easier. Okay, let's go back over here. And the stream's still going, at least. That's always good. I'm not talking to myself. Right, so any opinions? Interesting to hear what you'll say about what I'm doing. What do you think of the project? Is it worth pursuing? You know, obviously it's going to interest some people. You know, it's high voltage. That's the only thing. You know, it's one of those things you have to be really careful around. But you know, I'm hoping that people will find it useful and people actually want to make it. What I also expect to happen is when people do build it, is that they'll be able to refine the design, make it better. I mean, there's things like on that main voltage control dial, you could use the MOSFETs for that. And I did actually buy some MOSFETs, high voltage ones, and also had a high voltage regulator, which can do, I think it's 400 volts or something like that. So what test voltage would it go to? Well, whatever power supply you put up to, basically. So I've designed for, I think 550 volts is the absolute max it can do, or 500 volts, something like that. But it depends on what resistors you use. So all it is based on, really, the limiting factor, is the voltage divider going into Arduino. So, because that's just tuned to give a 5 volt maximum level to the Arduino at maximum voltage. So whatever you want to set your maximum voltage to, you can adjust it if you want. You can go higher. You could do 1000 if you really wanted to. But obviously you have to provide your own power supply to do that, and you know, tweak it to do that. So, but then all you have to do is tune the voltage divider resistors values. You know, so I've got a 5 mega ohm, well, it's 4.7 mega ohm, and a 47 kilo ohm resistor acting as a voltage divider. So that means that around that 500 volt mark is the maximum voltage into the Arduino at 5 volts, which will get clamped by a Zener diode, which is part of the protection circuitry in it. So if you want to tweak those resistor values to be something different, maybe changing a 47k down to, say, I don't know, a 33k or something like that, or 22k, around that sort of value, you could double the voltage, right? So if you put a 22k in instead of 47, you could use twice as high voltage. In the firmware for the Arduino, what I've done is I've written in a bit which will, let's get my face on here, eh? Let's do that. Disk and face, here we go. Yeah, a bit more interesting. On the Arduino, there's a bit in there where you can use, you just set the resistor value, you just tell it what value resistor is in there, and it will calculate the divider to try and simplify it. Since the paid website days. Oh, okay. Oh, the Radio Mod site. Yeah, that still goes. That's still going. Although I think the PayPal code's broken up. I don't have any payments for quite a while. I really need to look into that. Oh yeah, cool. Yeah, it's cool. Oh, it's been. This site was at 96, 97. I think I launched that site. Something like. Yeah. So yeah, in theory you can put any voltage you want into it within reason. You don't. I don't know about kilovolts. 10 kilovolts or so. That's high. You probably want to drop that down before you go into the unit. Yeah, that's a big voltage. Although I've got some isolation slots in there, I don't think it's going to be enough. Not for that voltage. That's something I've got no experience of anything that high. Even this level, I'm really pushing my experience levels. I know a little bit about it, but this isn't something I normally work with. Apart from test gear and fixing, where it's got these kinds of levels in it. I might let's quickly show the Arduino code as messy as it is. Let's just pull that up. Actually, I'll show you this window first. Let's find out first. Here we go. Oh, look, I've moved down the bottom there. Okay. So this is the Bango page for that high voltage boost converter. Okay. As you can see, it does 8 to 32 volts that they claim, but my testing is showing 11 volts is really like the bottom end. Oh yeah. Canon 2000, you've been hanging around for a while then. Yeah, I mean the CB stuff in my country is pretty quiet. It's not a lot of demand on it, but that said, I've actually got 2 radios sitting behind me on the floor, which I'm supposed to be working on. I've had for quite a while actually. I've had one sitting about a month. Oops, I kind of forgot about it. I've given one as well during the week to work on too, so I'm actually going to do some videos on those. I won't do it live. I'm not quite sure what's involved in them yet, so I'll probably video them, put them up, and I might do this weekend actually, and put them up within a week maybe. I'll see how we go. Now sidetracked. Right, bang good. So that's the voltage divider, voltage boost converter there. So it's about $10 New Zealand, as you can see there. And these are the specs. So it looks okay. It runs at 75 kilohertz. I mean, you can actually hear it squeal a little bit if you put really when you got the. I think I had the voltage turned right down. I think it was, and I could hear it squealing. Just very slight, very slight, really quiet. I could barely hear it. Oh, thanks for the thumbs up. That's always good. It helps. It does actually help. Thumbs up or thumbs down. Actually, it doesn't even matter. It doesn't. Any kind of activity on a channel helps it to be ranked higher in YouTube's algorithms, and then more people get to see it. And so you think, just clicking a button and on the page doesn't, giving it a thumbs up, it's not insignificant. Well, it does actually help the channel. So anyone that does that it's great. Which is why I try and promote it as much as I can, as well as trying to get people to remember to subscribe, because it's only about, I think it's about 20% of people watch a video is actually subscribed. So I think that's sort of watch a video then go away and forget to do it. That's why I'm always saying it, and you see other YouTubers always saying it about subscribing, because if you watch the whole video, then if it interests you at all, then you should subscribe. So yeah, there's the specs for it. So as you can see, it only does up to 390 volts max, but that is dual rail, right? So they've got different options. You can see on this one here, it doesn't have the other capacitor installed just there. Can I make a bigger view? Alright, so that's where the other cap is, and it's also got the missing terminal here. We'll go that view. There we go. See a bit better. So on this version it's not installed, but it looks like the transformer is the same transformer. It doesn't look like that's been changed. Okay, so if that's the case, then you probably just add a cap and add a terminal, and you've got a dual rail supply. But it's a nice little board. It's got a little output on there, as you can see, for fan. If you want to hook a fan up to it to help keep it cool, if you need to. I mean, I don't know. It may not be necessary, but I've been inclined just to shove a couple of screws through a panel and screw this thing straight to a panel and cool it with an aluminium panel. See if that does enough. But obviously, it depends how heavy you're working at. But so yeah, that's the unit. And let's put up some Arduino and I'll show you the code. And actually I'll show the board first. I'll show the revised board. So yeah, CB work, as I was saying, is pretty quiet in my country. There's not a huge demand, which is why you don't see many videos of me doing CB work, because it's usually around Christmas time is when I seem to get surges in demand. It's quite interesting, really. Get this thing opened up. My stomach's growling. I should have some dinner. Well, lunch. I'll do it after the live stream. Let's drag this up here, hopefully. You're kidding. It won't. Really? Oh, is it because I got this set to full screen? Maybe that's what it is. Okay, I can close it off now. Let's shove this up here. That's what it was. I just set full screen when it let me slide the thing up there. So yeah, CB work is pretty quiet, so that's why there's not that many videos on it. Yeah, thanks Sonia for your help. That's always good. I think watching the whole thing isn't really necessary. I think because I do get advertising on the videos as well. If it's less than half an hour or less than an hour, I won't put any breaks. I won't put any adverts in the middle of the video. Right? If it's more than an hour, then I will put an advert around half an hour. If you see anything more than that during the video, then it's YouTube adding them in, not me. So if you see stupid advert quantity in the video, let me know in the comments or something, because it's happened more than once where YouTube has slapped video adverts in it, and it's just get bloody annoying for everyone. And that's not what I'm trying to achieve. I have one at the end, the one at the beginning, one at the end, and if it's a really long video, I'll stick one in the middle. That's all I do. The advertising revenue is small. I'd rather have happier subscribers than the extra dollar I might earn. I say some of the videos, cool. Yeah, I mean you can do that. It's stuff you want to refer to later on. That's good. Alright, so as you can see on the top screen there's the circuit diagram for the board, and it's very simple. So let's zoom into each section and let's explain it. So this is the main 5-volt voltage regulator. Technically speaking, this isn't necessarily needed, but I tend to over-design things. I always over-engineer. So I don't like to run things at the limits. I always like to be well within what they're capable of doing. So the Arduino board has got a little voltage regulator on it which can run the Arduino. And you could kind of run the LCD display from that too. It'd be pushing a little bit, but it could do it. But I'd rather not stress the system. I'd rather just have this separate voltage regulator here, 5-volt supply, which runs the Arduino and the LCD display. And this can handle an amp or so. I think it's about 1.5 amps this one can take, I think, remember rightly. And so it's fine, well within what this can do. This is just sitting there basically. It's not hardly working at all. Alright, so it doesn't get warm at all. It's not doing much. I could actually use a different regulator. I could use a small one. It would work fine. But this is what I have, and I quite like these regulators. Nice and simple. Alright, so that's a nice, easy part of the circuit. Now this is the voltage multiplier section. And what I've actually done on this, it seems a bit strange, but I've actually taken out C4 and C6 on the one I'm working on right now. Now, in theory, you actually need C4 in there in order to double it the first time round. But what I've got is I've got a smoothing capacitor across the main supply which comes out. And what it's actually effectively doing is replacing whatever capacitor is on this rail. So that capacitor there is being replaced by the smoothing cap I've got in there, which is a 22 UF. right? And because it's between ground and the rail, it's polarised, whereas these can't be polarised. So, because they're effectively in series with the AC rail, that's the way that works. So I'm getting doubling because of these capacitors and the other one across the supply, which is a bit of a quirky thing that happen. If I don't have the PCB connected to the multiplier, with that little jumper block, then I only get a rectified AC coming out, which is about 290 volts DC, right? Because it hasn't got these other capacitors running. But, yeah. Oh, yeah, pay for YouTube Premium. Yeah. I've got the same thing. I've got Premium. They've changed it now. They've changed it. Oh, yeah, Premium is the new word. That's right. It was called Red, wasn't it? So yeah, I've got the same thing, Premium. So I don't see adverts either, which is nice. It's only a small cost, and yeah. So that's the voltage multiplier. I mean, this is basically a standard multiplier circuit, and you see here I've changed the value to 2UF. Right. I'm still not 100% sure that 2UF is the correct value. I think basically a case is as big as you can fit in there is really what is required. Voltage wise, this is pushing it a little bit, 300 volts. Depends on what voltage input you're using. Now I'm using 220 volts coming in, so I'm actually exceeding this voltage across that cap if I had that cap in there. But say I've taken that one out, so it doesn't matter in this case. But if you were running a 220 volt supply, you really need more than 300 volts. I was measuring 460 volts, I think, when I was running high voltage and supply line. So it's stressing the cap. I'm surprised it didn't blow actually, but it handled it. And but these ones are okay. This one doesn't matter so much. But if you've got 115 volt supply, then 300 volt is fine. That's why I had that value in there originally, because I was planning on using 115 volts. And so I'm actually revising that. I think I'm going to change those values a bit more and just change up the voltages. But trying to get that size cap, again, it's expensive. As soon as you start increasing that voltage and the capacitance rating, I think I was looking yesterday, about $16 New Zealand for one of those caps for one. And so if you need 4 of them, that's a bit of a hit. It's quite expensive. Considering the brains of the whole thing costs probably, well, the Arduino Pro Mini, you can get those for about $3, I think. And I think the variable pot on the front panel, I think it was about $10 for that high wattage pot. The LCD display, I think it's about $20 or $30 because it's a SparkFun one. You don't have to use that. You can always get a cheap parallel one and hook that up instead. Yeah, so part-wise, it's one of the most expensive parts of the whole unit would be the capacitors. So it's a bit ridiculous, really. So I'm not sure about that. Anyway, let's move on. Zoom out slightly for this bit. So there's obviously the Arduino. This is the footprint I designed for this thing. Basically, I made a footprint for the Pro Mini and an Eagle. So you can just get a Pro Mini as a part and put it in. And then you can just use those terminals. That's why it's done this way. And there's the rest of it. Okay, so this is that jumper block here. So you can see when you've got those 2 pins go to the voltage multiplier, and that's the common rail there. This is basically a test point, but also allowed that for the ability to inject your own voltage from a different source instead. You get occasional buffering again. Let's check my stream control settings. No, it's looking okay right now. At the moment it's okay. It's not dropping any frames now. It must have just gone through a bit of a glitch. Yeah. Okay. I'll drop the quality some more, shall I? Just to help it slightly. Bit rate's getting pretty low though. That might help slightly. So that's the high voltage section up here, and let's zoom into that bit. So there's that big cap I was saying I've got installed across the power supply, which is effectively replacing the one in the multiplier, high voltage multiplier. Okay, so that's effectively replacing the one I've taken out. And so it's 22 UF, so that is really good. I've got it in there for smoothing, mainly for smoothing. And so that's got a 500 volt cap. One I've got installed right now, I think it's a 450. Yeah, 450 volt is what I've got in there now, so that's kind of my voltage limit. And I've got a 500 volt diode specified here as well. That's purely clamping to protect the rest of the circuitry. Okay, in case something goes wrong, or It's also part of my thinking with this was the supply from the multiplier. It will give a really high voltage but a really low current, and as you drag the voltage down, the current will increase. Right, it will be able to provide more current because you're running on a sine wave. Okay, so the bit under the sine is the bit you're actually using. Okay, so the lower the voltage, the more power you have from it. So this, in a way, is also acting as a bit of I don't know, regulation, I suppose, in a way. So this voltage in here could be coming at 550 volts, and this would clamp it to 500 and help smooth it out and give you a more consistent current and more consistent voltage, which is the main reason I did that, really. And again, this thing is just like another test point. Okay, zoom out to here. So that's that pot that's on the front panel here. So it's got the main rail comes in here and ground that side. This is what I'm saying about needing to have a high wattage pot, because it's across that big high voltage rail. So that's something I'm not completely happy with at the moment. What I'm kind of thinking with there is that a MOSFET design would be better. Because I don't like having a high voltage pot there, or high wattage and high voltage going across it. It's pushing it a little bit. Even that one I've put in there now, that does get warm. Not as badly as the other one, but it does get warm. Now the thing that is an option with that is to actually change that resistance value. So I've got a 100k. If I made that a 220k or something like that instead, or 200k, whatever the next value up would be, it might be 150 even, that would help, because it's got less power running through it in a way, because it will see less of a load in itself, which will help. But I don't like that design overly myself. It's working, but maybe someone wants to design a better way. I did buy some MOSFETs somewhere. I think I did in a mailbag. It would have featured in a mailbag when I turned up. So I did buy some high voltage MOSFETs, which with this in mind of maybe using MOSFETs for it. So I may still go that route yet before I actually make the final design. But maybe something add on to this revision. I'll probably build something up and play around with it and see how it goes. But yeah, it's quite likely I'll do that, because then you can just use the MOSFET to control the current going through there, or the voltage going through there. Obviously you have to have some kind of loading to keep consistent, but yeah. So this is the takeoff there for the supply voltage. So this bit here, that's a 5 meg, which I've got as actually a 4.7 meg in my case, and a 47k. So that's that voltage divider with a 5.1 volt Zener clamping it with a smoothing capacitor here, just to take out any noise, just to give more consistent readings and make it read a bit easier. So that's the supply side. There's that 10k resistor, which I've got standing up off the board. I've changed that, actually. I need to change that value. I forgot that. I've changed that value. It's no longer 10k. It's now 5k. Or 4.7k. Let's do that. Because that's what I had. I had it in the drawer. The voltage drop through it when I was putting a big load on there was a bit too much. And I actually started noticing the resistor I had in it started burning. So I've changed that resistor to a high wattage one and a lower value, just to help the power dissipation issue through it. And so far it's been fine. It seems to resolve the problem. Now that's that switch. I was saying I've put those terminals now on the board for the switch. So switch high, switch low, which goes to ground for that resistor. That's a drain resistor, and the common. So obviously I haven't drawn it as a switch on the board because I want wire holes on the board. I mean, there's probably a better way of doing this, but I just wanted pads on the board to run wires to, and this is just a nice simple way of doing it. It's a few pads on the circuit. So then the common goes over to the actual capacitor or device under test, where it's going to be. I'm assuming capacitor most of the time. It could be something else. And again, you've got another circuit here, exactly the same as the first one, which is to detect the voltage of the device under test. Right, which is all the reason that resistor's in there for, is to create a voltage difference and to provide a bit of a buffer there from excessive current. And obviously those device under test terminals, those go to the front panel, or the banana plugs or banana sockets. Now this is the ammeter option, which is that little jumper, which I didn't point out, but there's a little jumper on that board. So it's also got some pads on there as well, so if you want to put an analog ammeter in it as well, you could do that. It's connected to those terminals and remove that jumper, and you can have an analog ammeter, which I think would probably be quite nice. I quite like analog needles for quick moving readings. I prefer analog to digital for those things. So anyway, currently I'm not using those terminals there. I've just got the jumper on there, so I pass it straight through. There's a shunt resistor which detects the current. Right, so all that's doing is measuring the voltage drop across that resistor. So if you want to increase the resolution so it can measure a lower current, you just increase that resistor value and change that value in the code of the Arduino, and then it'll compensate for it. That value there, you measure that value before you install the resistor, and you put that into the code, and it calculates what the drop will be across it, and so it knows how to do the calculations. So I've tried to keep it simple in that way. And obviously I've got another clamp clamp diode here, just for over voltage protection in case this resistor burns out and goes open circuit. It'll clamp it, and that way you're not shoving 400 volts into an Arduino. Right? And need another smoothing cap there as well for that input. Right, so that's it. That is the circuit. It's pretty simple. Now let's bring the circuit board up, the layout. And this is the revision I've done in this area here, basically, to the existing board. So there's that big resistor which I was saying I had to change. Those are the terminals that go to the switch. Those are the device under test wire connections. There's the DC input from the power supply you're using. These are the high voltage AC input over here, neutral and live. If you're using the onboard voltage multiplier, if you're not going to use that, then you don't need to use those connections. There's an earth terminal there just for the sake of having one. I'm actually going to try and I've got to tweak this board. These are holes in the board for mountings. Now, why I actually wanted to have it is exposed copper there. So when you bolt it down on a standoff, it clamps that to the chassis in order to make sure the board is at the same potential as the chassis to earth it. I want to do that on those holes, but I obviously when I did the first specification, I just did a hole. I didn't actually do a pad around them, so I need to actually figure out how to do that. And it's not something I've done yet, so I need to do that. What else am I looking at here? Oh yes, the connections here for the pot. So that's where the pot controls go on. They're just wired on. But I've got wires running to it. I've put a pot mounting position in case someone wanted to do. And that pad there is actually just another earth connection. I should rename that actually. There you go. And there's that clamp diode there, which does that high voltage clamping, and there's that dropper resistor there. And these are the inputs. So if you want to, there's a test point for supply, test point for the high voltage, test point for the supply voltage for the common. Right, so that's before the shunt. Before the dropping resistor. So you can measure the high voltage supply here at the common, or you could use that as an input, running a wire to it. So that's the plan there. What else is there? So obviously all the inputs and stuff on the Arduino. So these are all basically vacant. So I've only used A0 through to A2. Those are the analog inputs for the voltage measurements. and I've currently got it using number 9, pin 9, for the LED output. That's something I was actually thinking about building onto it. Actually, I was thinking about that. I might see if I can squeeze it in. Oh yeah, there's a gap. I'll put it up here. What I was looking at was putting a resistor on the PCB for the LED dropper, because obviously the Arduino puts out at 5 volts. So, or 0 volts, depending on how you wire it up. But I've got it programmed for always do high as an output, and I rarely use the low as an output. So I could actually run a connection up to here, put a resistor up here or something, and then you just have the 2 wires go to the LED. You don't have to worry about putting a dropper on the LED itself. That's something I was considering doing. I should actually do that, just to simplify the design a bit more, make it easier to build. But right now all these pins on this side are vacant. I think, apart from, which pin did I use for the display? I think it's pin 2 actually. Yeah, I used pin 2 to run the LCD display. So the serial's coming out of pin 2. Alright, so pin 2 and pin 9 are occupied in my case. But you can make those any pins you wanted. I mean, you could use these ones over here if you wanted and keep all these ones free. I mean, whatever. Depends how you want to do the film with. Okay, so that's that. I've got some other stuff on the works too. I've got so many projects here. It's just ridiculous. I just don't know how I'm going to find the time to get it all done. Cancel that. Let's do a save first. Alright. Close those off. Finish with that. Let's go back to the desk view and do that. Close Eagle up. I was going to show you the Arduino, wasn't I? That's right. The Arduino code. Let's fire this up. Get up there. And that one again. So there's the Arduino code right now. Comments and all, and bugs and all. I'm sure there's bugs in it. I tend to be quite a long code. I put lots of detail in, comments, layouts, things like that. I mean, you could make this much more concise, but even with my code, it's 225 lines. Alright, so it's not much. It could be made much smaller than that. I've got stuff in there which probably doesn't need. I've got bug test code in there. I've got code in there for running the serial monitor, so you can actually run it from a serial on your computer. So where the Arduino is plugged in, you can actually plug the Arduino into the computer at the same time as testing. You can do that, it's fine, which is the beauty of having that isolated supply. So there's no high voltage possibility going to the computer. It's quite good, which is why the earthing is also important on the casing. It has to be earthed. But you can actually read the serial data going to the computer as well when the Arduino is plugged into it, and that's all in here too. So up the top here is all the calibration data. So in here you can put in the resistor values for the dividers, and then it will calculate what the scaling factors are. It does it for you, so you don't have to try and work it out. But you do have to get these resistor values very close. Ideally you measure resistors before you install them on the board. Then that at least allows you then to know what they are. Because once you're installed, you can't measure them, not accurately, because they've got other components around them which affect the readings, so you can't actually get accurate readings once they're installed. But measure them before you put them in and you'll be pretty good. So what I've actually done here, I know these ones are really, really close, so like 47.16. That's obviously the smaller value on the dropper, on that divider. And I'm tuning this value here to give me the more accurate voltage readout. So I'm just measuring it with the multimeter and checking the display. But what I'm finding though is that it's not linear. So especially towards the bottom end, it's about a volt out. I can get the top end really close. I get it pretty much, within 0.1 of a volt. But as you come down in voltage, it drifts out. So it could be tweaked. One of the things we've got in here, just there, is the voltage reference value. So that's probably to do with the issue. I'll see my stream's playing up again. That's not good. You can measure the voltage reference that's on the Arduino. So you can actually measure what the voltage it's using. It's on one of the pins, which is pin 20. Right? Pin 20 of the 328P. You can actually measure what voltage the reference is using. But it drifts. So unless you're using the internal voltage reference, like the 1.1 volt reference that's in it, you're not going to get a great stability. But if you use a 1.1 volt reference, you can't use a 5 volt input on the input pins. You have to use a 1.1 volt max reference, which limits the scaling and stuff like that, and increases issues, and it just makes it harder to read, and it'll be more susceptible to noise and that kind of stuff. So really, you can inject your own voltage reference, but the Pro Mini doesn't have an input for it. There's no pin on that board for a ref pin. There isn't one. Some of the other boards do have AREF pins, and in that case, if I was using one of those boards, it'd probably be better, because then you could put in a 4.096 volt reference, chuck that in there, and that'd be better. That would actually be an improvement. Even though it's got a lower scaling, it'd be more accurate. So what I'm doing here is just putting in the voltage I'm measuring at that point, and I have found that it has needed tuning, it has drifted a little bit, so it's one of those things to watch out for with it. This value here is the shunt resistor value. That's the actual value of the shunt resistor, so it knows what calculation to do in order to work out the current. But that non-linear voltage reading across the range would be mostly due to the ADC and this voltage reference reading. But 1 volt, I'm not worried about being 1 volt out. I don't care. To me, that's adequate accuracy. I'm not trying to do precision voltage measurements. It's just trying to give you a ballpark figure of what the capacitor is doing. That's what it's for. And I've also got this voltage divider ratio and current divider ratio here. I think the voltage divider one now, that's superseded, and the current divider, I think I also changed that as well. So yeah, that's what I commented out. I did change those. So those are no longer used. They were used originally. It's doing a calculation rather than a measurement in some point. Those were replaced by these down here as well. So the voltage divider ratio, but I changed the names as well. But yeah, so the code is actually, if you take out all the extra bits I've got in there and the bits that aren't being used now, it's probably, I don't know, 150 lines of code? 150? Maybe? I don't know, maybe less than that. So, yeah. So that's the Arduino part of it. And you see, there's not much to it, really. It's pretty simple. Now, what these other projects I've got on the way, which I'm going to give some sneak previews here. Let's clear some space on my desk first. Now, I've been given a piece of test gear recently, which I believe hasn't really had much exposure yet. I'll give you a little sneak preview of that first. So it's in this box here, and as you can see, it's a Siglent box. I'm going to be doing a proper video on this and proper teardown. I'm actually going to be doing a teardown as well. I've been given permission to do a teardown. Actually, you got suggested to me to do a teardown. So this is actually supplied to me by Taupaki Technologies, which are based in Auckland, New Zealand, but they cover the whole country. That's Rob. Rob's a New Zealand distributor. So I've done various test equipment reviews and things like that with him. This gear, so he's given me this one. So. And as you can see, it is still sealed. I'll be breaking that seal. On the front, here we go. It is a little power supply. Now, it's nice and compact in that direction, so it's still on a shelf. It doesn't take up much room, which is quite nice. I really like that. It's a single output, but you've got sensing on there as well. It's got a nice hard switch on there instead of electronic switch. It's got a nice hard one. I quite like that. Physical switch. And it's got some really nice features on it. Now, I believe it voltage is I think a 16 volt power supply. Yeah, 16 volt at 8 amp. There we go. Alright, so this is good for radios and things like that, radio work maybe, or anything we don't need a particularly high voltage, but you need a bit more current. Right, so like single channel, but it's good and it's got lots of features on it. So I'll be doing a full review on this. and it's got USB and Ethernet connections on the back there, so you can network it and look at it through LabVIEW software and stuff like that, I think. So I'll be doing a full review on that one, so it's a bit of a sneak peek. I'll put it away again before I drop it or something. That would be bad. Hold on a second. Get it right around, it's always swapping. Right. The packaging materials on these things are actually made to fit in specific orientations to protect it properly. Civil are very good at the packaging, making sure things don't get damaged in post and stuff. Right, that's that. What else have we got here? Oh, I've got this thing. Disk station, little dual bay disk station. I might do something on that. I don't know. I might do a little video just to show that. What else have I got? Oh yes. What else have I got? Down here, right down there, underneath this other desk, I've got one, two. Yeah, I've got 2 projects under there. I've still got a Fluke 5200A, which I'm still fixing. I haven't quite finished that. I need to get back to that. That's sitting there, and I've also got that Valhalla voltage reference as well, which half works. So I need to get back to that one as well. That's another project I've got to do. And then up there, I've got four projects up there waiting to happen. Bits of test gear. I've got up there. I've got a Fluke. Oh, I've got a few things up there which are Fluke actually. Let me go and read them out. Hold on. So I've got a HP 6181B DC current source. I featured these previously in when I actually got them in the mailbag and stuff like that. I've got a, what the hell's that thing? Valhalla, yeah, Valhalla 2101 digital power analyzer. I think that actually seemed to work, but so I haven't actually played around with it much. The, what's this thing? Oh, I can't see it. It's another Fluke thing. What the hell was that? I can't read the bottom of it. It's too far out the way. I'm a bit short, I can't quite see it. That's right, it's an 893A AC DC differential voltmeter. Right, that I think works, I don't remember. I'll have to look at that in more detail. And the other thing I've got here is a Fluke 540B thermal transfer standard. Now all these things are featured in mailbag, probably, I don't know, in the past 6 months. They've all featured in mailbag. Right, that's when they've all arrived in the past 6 months, and they're just sitting there waiting for me to get to them because I've just been so busy. What else have I got? I've got some CBs to do. I've got a couple of 2 radios to do. One of them's been sitting there for about a month now. I need to get onto that. I kind of forgot about it, so I'm sure the guy's waiting for it patiently. He hasn't contacted me yet actually, so which is I don't like to do. I usually, when I get a radio to do, I usually do it within a couple of days. But I wasn't set up for it at the time when it arrived. I wasn't ready for it. My bench still wasn't actually probably set up for doing CB work. I've got most of the gear there, but it's not all connected up. So I need to actually get that sorted out and get some radio work done. I'll try and do it this weekend. That should make some people happy when I get those finished. And I'll do some videos on those probably and share them with people which like the CB work. Okay, I think I've waffled enough. How long have I been going now? Hour and 20 minutes. Ooh, yeah, quite a long stream. So I think I might leave it at that, unless someone's got anything particular to comment on. I expect this will be more as a normal everyday stream, wouldn't it? What's this? What's number is this? This is yeah, that's what it should be called. Should be called that. I'll just change the name. Had the wrong name on it. Ah dear, on the whole stream. Right, I think we're done. Where's my chat window gone? You got some CBs, have you, Tonya? What have you got? Where are you anyway? What country are you in? I've seen you commenting on some other videos. I remember seeing that. Oh, what was I talking to you about? What was that now? Remember I answered something you asked me about? Brownie Mobile. Okay. Brownings are something I don't see. I think I've only ever seen one. They just don't get them. Yeah, because USA radio. Yeah. So yeah, we just don't get them in this country or even UK when I was over there. I don't think I ever saw one over there either. So, what was it you asked me about? I can't remember what it was now. There's something you asked questions about, and I told you something. That's going to bug me now. Ah, EV switcher. That's right. Yeah, which I've got sitting here actually. Right. Sitting right here in this box. I still haven't hooked it up. Another project I have to get onto. So here you go, sitting right there. I really need to get onto that too. I've got so many projects, it's ridiculous. On my house side of things, some of you may not remember that you know, I got flooded in January and I was basically homeless for a period of months. Well, technically homeless because my house was unlivable, but I was living in a motorhome and a garage. The garage has finally been physically fixed. I got to the plastering and painting yet, but it seems to be at least coming along. So hopefully the next week or so I'd actually have that finished. That'd be great. Better start organising the garage. That's another thing I've got to do. That's a mess right now. It's a real big mess right now. It's pretty bad. Cobra 40. Cobra 40. I don't think I've seen one. Let me just have a quick search and try and look it up. Yeah. New window, hold on. Right. No, that's not. It's a beer. I don't want a beer. CB radio. Cobra 40 CB radio. Ah, okay. Interesting. Really? That's not a 40. Let's give you pictures of a Cobra 29. That's not a 40. I don't see it. Let me have a look at my files. This is going to bug me now unless I find something. Where the hell is it? Where would that be? Let's just do a search, eh? Let's just try and find it on my computer. No. No, I don't have it. I don't have anything about that either in my files. I've got nothing either. That's going to bug me now. Is it a 40 GTL or just or limited or something like that? Do you know the full number? Yeah, this bloody Google search doesn't come up with anything. That's pretty useless. Oh, 142 GTL. That makes more sense. Okay, I'm familiar with 142. Yeah, 142. Yeah. Okay. I've seen those. I've worked on a couple of those over the years. Not many, only a couple. Again, not very big over here. Yeah, so what have I got to do? I've got what I was given the other day. So I've got another one in the box still. Galaxy 959, are you? Yeah, no, those things. They have to be careful with those, because they tend to drift a little bit. Those 959s I found a bit drifty. One of the fixes I found for them was to replace the 10 MHz crystal. Sometimes the crystals are a bit dodgy. So this is what I've got to do. One of these. Grant. Got to do a frequency conversion on it and a forward realignment. Actually, I might as well leave it on my desk because I need to sort it out. So I need to get to that today, actually. And I've got another one in a box here somewhere, which I think's a Cobra 29 GTL. Or Limited, sorry, Cobra 29 Limited. Which needs frequency conversion as well. Yeah, I mean, CB used to be really big. I mean, years ago, I'm going to show my age a little bit here. 25 years ago, nearly 30 years ago, I was a lot more onto, and I was basically on it 24 hours a day. You know, I'll be asleep and I'd have radio with me, well, on next to me, and I'll be, let's leave it on my channel. I have a channel which I'd use and nobody else would use it. And a little group of people I'd hang out with, they would come and talk to me to come up on my channel and say hello, you know, which used to be Channel 6 back in the UK, and I did it also over here in this country when I moved over here. But I found when I came here it was much quieter. Mostly just truckies use it, really. That's the biggest users. So they tend to bring radios in, and you know, they need to convert it to New Zealand frequencies, so I do that from time to time when I get asked. So it's not huge demand for it, which is a bit of a shame. You know. Once I think what killed CB, I think, was cell phones. I think cell phones is what's really killed it. You know, because before it used to be like the poor man's communications tool, whereas the ham radio stuff is for the slightly better off people. That seems to be the way it was, you know, working, and you know, so CB is what, but you know, you could get more easily and was simpler to use. Didn't need licensing, well, hardly any licensing, so it's less of an issue like that as well. So yeah, it's a bit different these days. You know, since CB cell phones came out, CB's started declining quite badly. You know, and there's very little work for it now. You know, I don't run it. No, I don't do CB work as a business. It's just a hobby. It's a sideline I do, just to help people out, really, more than anything. Yeah, cell phones have killed a lot of things. Yeah, I'm sure they have. At least, no, CB's still fairly popular in the US. I think it's probably where it's still most popular is the US. It certainly seems that way anyway, the impression I get. But over here, it's very low. I mean, there's been times I've gone an entire year without working on a single radio. It's been that bad. And there's been times where, especially around Christmas time, it seems, I might get 10 radios at once. It can happen. I've had that kind of extreme, so you know, it makes it a bit more interesting in that way. You know, very variable. Yeah, so it's. I do enjoy doing CB work. I like that troubleshooting process and going through and fixing them and finding what's wrong and doing that diagnosis thing, because you never quite know. There's lots of things it could be. Although you do, in some certain radios, you might see the same fault over and over again. A good example is VCO faults, or you know, a PRL that will die, or the PRL is usually pretty good, but I've had a few which have come along, been a bit of a curveball. The VCO problems on the old grants, like this one I've got on my bench right now, that's one of them. Those VCOs, because they're a custom unit, it's a custom module, it's a UHIC 006 or something, I think it is, from memory. You can't get them. They don't make them anymore. They stopped making them 30 years ago. So, you know, if those fail, the radio is pretty much stuffed, really. Sometimes you can eke a bit more out of them. You can make them live a bit longer. They start going and get a bit weak. You can do some tweaks and things like that to try and recover them, but oh, really? They're taking bandwidth from those things? Really? For stage mics? That's surprising. Frequencies those things use? I mean, they must be 800 megahertz range, surely. Must be what they're in, 800 meg? I think that's about what they are, aren't they? I'm not sure. I'm not that familiar with them. But I know that the lower cell phone band, I think it's 800 megahertz range, the lower one, which they're using for mainly for rural use, for its longer distances, because the lower the frequency, the further the transmission range can work. It's less affected by objects and obstructions. Okay. Well, interesting. Yeah, trying to radio stuff is interesting because things are nothing's ever fixed in stone. Anything can change. Even the fact there's still a CB band to me is actually amazing. I'm surprised it's not been scrapped. That piece of bandwidth there. I'm amazed that it's still available in many countries. I'm surprised it's not been given to something else. Things, the lower frequency is not particularly good for high bandwidth stuff. The higher the frequency, the higher bandwidth they can use, and the faster they can be. So a lot of digital stuff these days would be no good on those low frequencies anyway. Okay, well, digital anyway. Alright. I've actually been thinking about getting a wireless mic for when I'm doing this stuff. Working at the bench there, so I can have like a lapel mic or something and try and get better audio. I've got a mic set up. Well, right now I'm using the mics on my camera, so I'm using a DSLR camera now, which I'll flick around and show you actually. Right, it's up there, hanging off that abomination. And there's my desk and stuff that's there, awfully messy. So that DSLR's got bought in mic, and that's what I'm using right now. It actually seems to be reasonable. I did have a shotgun mic, which now I don't know where it is. I think I'll put it away. A little shotgun mic on it, which I did have on top of the camera, mounted on that assembly there, that bracket mount. Because it's directional, I was trying to get rid of any surrounding noise, like noise next in the neighbouring rooms and that sort of stuff. And the quality of the audio wasn't good enough. It was not a decent brand. It was a Boya mic, and I've had another Boya mic, my Defpom mic, which is a Boya mic, which I've used previously on my iPhone when I was recording with that. That's been fine. That is nice quality. And I've got another Boya mic there, which is also nice quality. It looks nice. It's good build quality, that sort of stuff. And this other thing I purchased just doesn't sound very good. It works. It does what it's designed to do, but the audio quality is just not there. 673 to 697 megahertz. Okay. Maybe I'll set up a scanner in that range or something. I don't know. See if I can pick up anything when I'm driving around town. Or just let's say being phased out now anyway, so it might be different anyway. So my DSLR, which I've been using that long. I've only had it for, I think I've had it about 3 months now. I've been trying to get to grips with it and get it better and get the video quality better. I've not been 100% happy with the video quality, but now I've getting my head around how I need to have it set up. It's getting better. I think the audio quality from it seems okay, but so I did try a plug-in mic and I wasn't happy with that one. So I'm thinking I probably want to look at a different kind of plug-in mic, or say a wireless one option. So then at least this audio quality and volume stays consistent throughout the whole recording. One of the things I have to do when I'm editing is adjust the audio levels and try and keep them consistent. Because if I'm standing up, I'm obviously closer to the camera, and if I sit down, I'll get further away, and so the audio gets a lot quieter. So I have to try and compensate for those to try and keep them the same level, which is a bit of a pain in editing, but it's just one of the things you have to try and do. So you may notice level differences in the videos because of that. When I was using the lapel mic on my iPhone, when I was recording with that, I had it mounted lower, so it's like an average height. So if I was standing up, it's about the same distance as it was when I was sitting down, so it tended to be more consistent. But that was quieter, and I had to boost it up about between 6 and 9 dB always. Sometimes 12 dB I had to boost it up by. This system, if I'm standing up, I don't have to boost it. If I'm sitting down, I have to boost it about 3 to 6 dB, pretty much. But yeah, I'm still 100% happy with it. I'm extremely tempted, and I'm trying to resist the urge right now to buy a DSLR camera. DSLR. I've already got DSLR. A 4K video camera. Whenever I get anything, I try and buy better than I need, because inevitably you're going to want to progress from that point. Instead of having to replace it in a year's time or 2 years' time, it will do you for longer. So it costs you more up front, but long term it will be cheaper. So I always tend to buy it more than I actually need it to be. I even engineer, and some might say it's a filing, but I don't think it is. Audio equipment restorations. Oh, okay. Using ultra cheap equipment. Well, do you actually have a YouTube channel? I haven't actually looked. I haven't looked to see if you've even got a channel. I probably could do, actually, shouldn't I? Can I click on anything here or not? No, I can't click on you there. I'll have to look you up. But do you actually have a YouTube channel? I'm always looking for content to watch. So I was going through. I was watching a whole bunch of dashcam footage from various places for quite a time. Then I got sick of watching that, so I'm watching a guy now that does panel beating. Quite interesting. He's got loads of subscribers. Is watching him repair cars. That's quite interesting too. So yeah, but it's always interesting comments. If you've got a channel, just let us know, and I'll check it out. So what was I saying? Yeah, so I'm looking at 4K video camera. I'm really tempted to buy one. They're expensive. Now let's just have a quick look, actually, and just I know what, because when I visited Dave in Australia just over a month ago now, you may have seen a video on Dave's channel, EV blog. Well, when I visited him and did a little video of him doing a teardown and a little assessment of the calculator I gave him as a gift, and he showed me then his production system and the way he does stuff, and the way he organises what he does. It's quite cool. So that gave me some ideas, and trying to emulate what he does as well, and the way he does things, because obviously with over 1,000 videos under his belt, he's got a bit of experience. Okay, I've got 400 odd videos now, but the production quality of mine is not the same as his. So I'm trying to lift my game a bit at the same time. Now this video camera is the one that the one that Jave is currently using now, which is only just purchased recently. That's pretty expensive. That's a good quality camera. Let's just see if I can find one in New Zealand dollars. I'm not quite sure what country that was in. Yes, here we go. Oh, wow. Okay. For me, to buy that same camera in my country, I'm looking at nearly $4,000. That's New Zealand dollars, so. Okay, I'll check your channel out. Have a look. Yeah, Dave is awesome, and he's a really great guy to chat to too. I spent the afternoon with him. I went up there, I think I arrived at midday, and we left at just after 4 o'clock. So we were there for like 4 hours, and it was great. We had a great time. I was over there with my wife. Oh, moving things around, probably can't hear me. I was over there with my wife, and she basically sat in a corner and read a book whilst I was chatting with Dave most of the time. But she was chatting to him as well. But when we were talking about the technical stuff, she just just kept to herself a little bit and just let me chat with him. It's quite good. But Dave's a cool guy. He's a really nice guy. I like him. The way he comes across on camera, yeah, that's how he is. It's the same guy. It's no different. He even took us down and bought us lunch. It's awesome. Okay. You just got another subscriber. Right. Yeah, 720p. I did originally record in 720p. Well, yeah, I've tried various formats over the years. Well, a couple of years I've been doing YouTube. I did 720p for a while, probably a few months, and I decided that it didn't quite have the resolution I wanted, and people kept on suggesting do 1080, do 1080. You know, and it did make a difference to the quality of the video. You know, 1080 looks like a good thing to go for, but 720 certainly, if you've got restrictions on broadband speeds and stuff like that. I mean, like I do. You know, that's the reason I went 720 originally rather than 1080 was because of the broadband speeds and the ease of doing the videos. Like if you're actually doing recording and then editing, the file sizes are obviously a lot smaller. So that's all part of that. But 1080 is what I'm doing now. But 4K would just mean I've got upgrade options later on. If I want to do 4K later on, I could do it. I'll have a camera. But I don't want to spend $4,000 on one. The ones I was looking at, I think they're about $2,000, and even that is making me sort of, I don't want to spend that money, you know. That's why I'm persisting with this DSLR, trying to get the DSLR to the standard that I need it to be. I mean, right now, I get better quality video off my iPhone than I do off the DSLR. Because of just trying to get the setups right and get the focusing range, because you got the aperture size, which affects the focus distance and things like that, so you got that range that the focus will work on. And by default the DSLR is a very narrow range, and when I'm trying to do the stuff on the bench, the bench top will be on focus, but if I lift something 6 inches off the bench, it's out of focus, and that's just no good. So I've been trying to play around with aperture sizes and stuff like that, and getting it better. But when you do that, then you get a darker image, and there's effects and stuff like that as well. Yeah, I mean 720 is fine usually for watching, but it's not a big difference between 720 and 1080 really. Quality wise, it's sharper, but it depends if you need to see the fine detail or not. And like for me, when I'm recording video, and I'm recording 1080 anyway, but when I'm editing, I'm staying in 1080. But you can always scale it down to 720 or something else in editing. You can't scale it back up. Well, you can, but it doesn't come out very well because you don't gain anything in quality. So I tend to start off big, and then if I need to, I can reduce it, which is the way to do it. Wow, that's incredible internet speed. My speed right now, based on the way my internet connection is going, I'm probably about 2 megabit, maybe 5, based on the way it's been playing up. The best I get is about 30 up and down. So I've got, I think down up's about 5 meg slow or something. So I think it's about 30 down, 25 up. That's what I get, and that's the best it can be. So I'm actually wireless internet, so I cannot get fixed line broadband here. There's no fibre optic here. There's no ADSL or VDSL, or there isn't anything. All we've got, as far as lines go, is dial-up. Right, 5K modem, dial-up, 5.6K modem, dial-up. That's it. There is no phone lines. So if you want broadband, where I am, because I'm rural, I have to get wireless. And there's only a couple of providers, and one I'm with now is actually pretty good. They've got really good customer support. If something goes wrong, they're right onto it. I'm really happy with the provider. But when I first got the connection here, I was one of the first, I think the first person in my town to get it. And I had awesome speeds, and it's consistent. It was the same speed day and night. Didn't matter what time of day. It was brilliant. But now I can probably see out of my window 5 other people that have got it. Right? And because it's wireless, you've only got so much network bandwidth and capacity, and before you get into modulation and crossover and various artifacts, from having so many transmitters on the same frequency range or same bandwidth. So since more people have been getting it, my service has been getting worse and worse and worse. And they are in the process of doing a new generation of the networking. it's not here yet, but they've done it in some other areas. So eventually it will come here, and when it happens, it'll probably be fine again. But the current generation is being overloaded, and so my internet connection gets quite bad. So streaming is a pain. I mean, the stream quality I'm using now is far below what I want to use, and uploading videos, say it can take a while sometimes. Depends on what time of day I do it. Yeah, well, again, it depends on the bit rates, and the bit rate I've got set right now is what am I doing right now? 1100 BPS. That's what I'm streaming at right now, or kilobits. Sorry, kilobits. Yeah, I'm doing 1280 or so kilobits per second right now. So 1.2 megabit, roundabout, so 1 megabit I'm doing right now in a stream. So that's not bad really, because I've had to bring that kilobit bit rate down for the video quality. So it's not as, the picture quality won't be as good as it should be, but yeah. So at best I'm getting 30 megabit upload, 25 megabit upload, 30 megabit download. That's it. That's the best I can get here. When I first got my iPhone 6s, they just installed a 4G cell tower, about probably just outside the town. I don't know. It's probably 4k away, something like that. 4 or 5k away. And when I did testing on my phone, I was getting 100 megabits on the phone. As soon as I installed the tower, I was getting 100 megabit on the phone. That's incredible. But now they've scaled it back and they've actually limited it, so you can't get anywhere near that on a cell tower anymore. And it's consistent. So it's not like an overload thing, where it's limiting bandwidth because of the overloading on the network. It's a rock solid limit. So I think that the telco providers have actually throttled it, so you can't get those high speeds, although the system's capable of doing it. One gigabit per second download. Wow. I can only wish. The annoying thing about fibre, right? Fibre is 10 minutes in that direction. 10 minutes in that direction. And 10 minutes in that direction. But I won't bring it past here. There's fibre, like 10 minutes in any direction around my house. There's fibre. And they've got fibre. But there's nothing in this area. This is ridiculous. And actually, that's one of the things that really annoyed me. When they were laying the fibre, this is a rural area, don't forget, this is rural. There's nothing out here. There's towns sparsely populated around the place, and there's the odd house here or there. Anyway, they did fibre all the way down this one road, probably 10k down this road, down one side. And then they stopped, turned around, did the other side of the road all the way back. Now, that fibre serviced about 6 houses. Right? 6. And well, what I should have done, instead of doing both sides of the road, is I should have carried on the same side of the road and kept on going to my house, and then would have serviced this entire town. It's just ridiculous. Anyway, that's bureaucracy and stupidity for you. Do both sides of the same road to service 6 houses instead of doing the same amount of effort and do an entire town. Just stupid. Oh yeah. Well, I mean, so right here, dial-up is the only fixed line kind of thing we can get. Here's dial-up, and it's just, and yeah, many years ago I used to run a file sharing server, and that was on dial-up, and it was alright. But yeah, that's a joke these days. Can't dream of decent speeds. My country is behind by a lot in many ways, and we also get overcharged for what we get given to. Anyway, let's just see what else is going on here. Alright, so anything else you want to talk about? What have we got? I'm sure I've got some other projects here I could show you. Must be something. I mean, let's just pull this up. I mean, it's all very well having a Q&A and stuff like that, but something Dave did. When I was visiting Dave, he talked about my nickname, Defpom, and he asked me on camera, oh, do you want to share it? It's like, if you want, but then he didn't pursue it. He says, maybe you can ask on a Q&A on his channel. And someone asked about in the comments on this video. Now, if I can pick this up, that's something you can probably see in the background actually, just there. See that? My little 3D printer, my little Ender 3. I've used it a bit. I've made some parts, and I've actually made hand. I think I did some videos on it. It's just too heavy. I'm not going to pick this up. It's a Valhalla AC calibrator. I'm going to be working on that one. That's probably one of the next things I'll do, I expect. I've got the Fluke 5000 sitting here. Sorry, 5200A. If I can stop mumbling. That almost works. It's like 99% there, but it's got some noise on the output, and at the very low, I think the low frequency range was very noisy, and it wasn't clean. It was not good signal. So that I need to get back to. I've got some ideas of what it is. I actually had to buy some capacitors for that, some tantalum capacitors, because I didn't have any in stock. And at the time I was kind of sick of working on it, so I've just put it to one side, and that was probably about 3 months ago now. And I'll be getting back to that. Once I try and catch up a bit with my current projects like the leakage tester and stuff like that. Yeah. Let's do this. Let's just change that. Right. So I will be going back to that and trying to get that little noise issue sorted out. And one of the things I've got is I've got that Keysight scope there, which I won. Keysight did that promotion wave, they called it. And I was one of the finalists in their Test to Impress contest, and they gave me a scope. You may or may not have seen it. If you're a subscriber back then, you would have seen the video from it, but when I received it. But I haven't actually used it much yet. I haven't done anything with scopes for a little while, so I'm actually keen to get on there and play around with that scope and actually start using it and do some test gear repairs and actually get into doing some technical stuff again like that, and some more repair work. It wasn't a BBS, it was a file sharer, so it's like sharing software and things like that. It was a little bit shady, I suppose. Yeah, I don't know. Many years ago in my youth, just do stupid shit then, don't you? So yeah, long gone. Okay, so your HDMI switch is on its way, hopefully. Well, project side of things, I try and keep things a bit varied, but I'm finding I'm trying to focus on test gear, because in order to do more electronics work, sometimes you need more test gear to do those things you can't normally do. And so I've got to a point now where, as far as test gear goes, I have probably everything I need. Maybe there's a few things I can think of which I'd probably like to get, but they're not essential. I've got nice scopes. I've got, especially the Keysight one now, I've got 2 nice scopes. That Keysight one's got some great features on it. I've got a really nice multi-digit, was it 6.5 digit multimeter, good frequency counters, modulation testers, IF signal generator, IF signal testers. I've got that CMU 200 which I picked up recently, which I've yet to use incidentally, which will probably part of the video I do on the CB radio work when I'm working on those. So that that's a signal generator and audio analyzer, some modulation stuff in it. It does a little bit of modulation checking on it, not a huge amount. Spectrum analyzer in there, things like that. So although it's not like a highly spec'd spectrum analyzer, and it's got a spectrum analyzer in it, which is better than what I was using. I've got that old HP spectrum analyzer, which is currently on his desk here. Is it 8950? Isn't it? Oh, what's that number? Is it? Hold on, I'm trying to read it now. 8590A, right? A spectrum analyzer. So that works, but it drifted around a lot, and it wasn't as nice. And from what comparison I've done with the CMU 200 spectrum analyzer and the HP one, I'm getting better resolution on the CMU, so that's pretty good. Let's see. I've got an old Dick Smith Electronics oscilloscope up there, analog one. That's 60 megahertz. That's the first oscilloscope I ever purchased. That was about 20 odd years ago, and that was, how much was that? That was about, I think it was about $1,100, about $1,000 New Zealand to pay for that at the time. I mean, that's silly money really, considering what you can get now for $1,000. I've got that, and I've got a Tektronix scope tucked away somewhere, Tektronix 2432A, which you would have probably seen in my videos on the bench. It's now put away. It's tucked it away so I needed the bench space on the shelving. I didn't use it very often anyway. What I did like about the Tektronix was that the had a output on the back from the channel 2 input, so the channel 2 was fed right through and buffered and amplified and went out the back, and you could use that to run a frequency counter, so you could be probing on a test point on like a CB and doing alignment or something like that. In my case, you could be probing a circuit, measuring the frequency and checking the waveform on the scope, so you can see the waveform, you can find the waveform, view it, see how clean it is. Then the output on the back of the scope would tell you the frequency on a high resolution counter, right? So I'm using a crystal oven oscillator on a frequency counter, and I'm getting really high precision readings, which you can't get from an oscilloscope. You know, oscilloscope will give you ballpark readings. You know, it'd be around about, accuracy varies depending on the scope, but that's the way I had it set up, and it worked beautifully. You know, because I could find the signal using the scope to see it and check the quality of the signal, and then I could read the signal on a high resolution frequency counter, which is something I wish modern oscilloscopes had. You know, a throughput. You know, the same thing. I'd like to have that on modern scopes, but they just don't seem to have it. At least not the ones I've seen, anyway. The Tektronix scope I picked up for $800 in New Zealand probably about 10 years ago now. Yeah, 10 to 12 years ago I picked it up, and I had to repair it a few times. I've done some videos on that, although the repairs I did weren't necessarily right. Like I had some failed tantalum capacitors in there, and I didn't have any tantalums that would work at the time, so I had to put some electrolytics in there, so not ideal. So it worked, but it probably is not helping the accuracy of the scope, so I probably should go back one day and put the right parts back in. But yeah, so now I've got the Siglent SDS2102 scope and the Keysight DSO-X, what the hell is that? DSO-X 1102G, which is one that's got the built-in generator on it as well. So it's a fully optional scope, is one I gave me. It's fully optional, which is brilliant. So yeah, I mean, test gear wise, I've got so much stuff now, but a lot of it's old and things I've fixed. I mean, in the modulation meter I've fixed. So yeah, actually I'm scaling back a bit now. For some of the other stuff in a Tektronix scope I'd fixed, and there's a few other bits and pieces. I had that Marconi 2305 modulation meter on my bench for quite a while. In my early videos you would have seen it taking up quite a large piece of my bench space, because that's got that's ovenized crystal oscillator in it, had a high accuracy frequency counter and modulation measurements, and I repaired that as well as in a previous video. And a lot of the gear I was using are things I'd fixed, and they're old, but they worked after I fixed them. Oh yeah, the stuff I feature on our channel is like way up there. You know, everyday people that do electronics aren't going to be buying the gear that they tend to feature in their channel. They should be doing more videos on the more I won't say basic, but the more accessible equipment. That's probably the best way to put it. All right, you know, people which tinker around with electronics and just want to do a little bit, or like I do a little bit like this, and tinker around with things and trying to do something interesting, or repair basic things. There should be more features on that equipment and how to use those kinds of equipment, because they might find then they sell more of it too. Who knows? What else are we talking about? Let's see. Oh, maybe a little bit. I don't know. You may have seen a couple of mailbag videos. I did some things on IP cameras, IP security cameras. So recently I actually did an installation at a local business. I installed a bunch of IP security cameras and all networked up, and I was on the internet and that sort of stuff, and you can remotely view them and stuff like that. And I did the job for him. I didn't charge him any money because he's done me lots of favours over the years, so I paid him back and by doing it for free. I only charged him for the gear I purchased. So he was thrilled about that, obviously. And, just returning favours basically. And he got quoted, I think he said $4,500 New Zealand for a similar system to what I put in. And the system I put in ideally would have been about $2,000, but I managed to get some cheaper cameras for a couple of areas, because I didn't need super high quality, high end cameras to cover the office, for example. It just it's a small space. It didn't need something which can cover a wide area with high resolution. It just didn't need that. So it's still a 1080p camera, but it didn't need to be the same quality level. It could be, instead of spending $200 on a camera, I spent $60, and it's still adequate quality. Yeah, that thing at Keysight there with 10,000K several days, a few months ago, that was the wave contest, and part of that was a test to impress, which is how I got my Keysight scope there, because I was one of the winners on that. So that's actually part of that promotion they did. They liked the fact that I'm a YouTuber and I'm sharing what I'm doing to people, and trying to help people fix their gear. They quite liked that, so that they gave me a scope, which is brilliant. This IP cam system I've installed, it's got a standalone NVR, network video recorder, with its own hard drive. It's all isolated from the computer system, so it's got its own network, but it's connected to the main network, so it's all fairly robust. But I know you can use computers to record DVRs, NVRs. You can record cameras like that, and you can actually. Some IP cameras have got memory cards built into them, so you can actually put a SD card in there and record straight into the SD card from the camera. And you can get quite a bit of footage on one of those. But the only problem with SD cards is actually they are considered consumable items. They wear out. So in a year's time, you have to replace the SD card, or maybe 2 years, depending on the quality of the card. Who knows? But they can wear out, and you may not know until you go to record the footage off and find there's nothing there. So you can have just standalone cameras. Standalone ones, you can just use the camera by itself on your network and remotely access it. You can do that. The IP cameras these days are really good. The quality is pretty good. Even the cheap ones do have good features. Even the cheap ones, I was buying $60 cameras. Well, I bought a couple of $60 cameras for this guy, and the feature set is fine. It did everything it needed, and the quality was fine. It was all good. Seems my stream's dropping out and coming back again. Interesting. Oh yeah, RAID system, yeah. You definitely want to have things backed up as well, and RAIDs are perfect for doing that because they're designed to have high disk activity. One thing, the RAID drives are more designed for heavy duty usage, right? But you can get hard drives which are designed for IP camera systems or network camera systems, which are designed for long, heavy duty write sessions, right? So they're constantly being written to all the time because the camera's obviously constantly streaming, so the drive's constantly being written to, and you get there's a different class of drives. I think Western Digital do I think it's a purple range. I think it's called Western Digital Purple. They're designed for camera systems, so they're designed to have that constant writing, that heavy workload. So that's something to consider. If you have an issue with your RAID system failing because of the drives wearing out, it may not be an issue, depends on the quality of drives you've got, but some of that is something to consider too. PTZ cameras, yeah. I actually did some reviews for an Amazon store. I'm not quite sure the story is there. I think they did change names halfway through or something like that, and or it's related stores, or maybe it's like a subset of the company or something. I'm not quite sure, but I did a review on it was called a PTZ, but it's actually, let's call it a zoom camera. It was just a zoom, but it's a big chunky camera, really good quality. Build quality was impeccable. It's a brilliant camera, and big dome camera, heavy duty thing, pretty hard to smash, I'd imagine. And that's a zoom on it, and that had a really great zoom. Quality was great. And then I did a review on another camera from kind of the same company, but it's like, I don't know what the story was there, say. And that camera was half the size, and that's just a standard camera, no PTZ or anything like that on it. But I've recently purchased some cameras, which actually you can just see just there. You see it, right there. There's a stack of 3. I actually got 5 cameras sitting there. So I'm actually in the process of upgrading my entire camera system on the house, because my old recorder failed. I did have an analog system in place with good quality cameras and stuff like that, but it's an analog system, and the recorder failed. And I actually got a bit of video on that. I haven't done anything else apart from record it yet, but just trying to diagnose that DVR which has failed. And I didn't really buy about too much because I was planning on replacing it anyway with a network system, because I did do a review on the NVR itself, the actual recorder, the storage unit. I did a review on that probably close to a year ago now, actually, and so I had that sitting around. I plan to use that and these high quality security cameras and upgrade my system with those. And these little cameras we've got here, 3 of those are PTZ cameras. Although they're only small, only that kind of size, they're pan-tilt zoom. They do all those functions, so they work really well. I plugged them in, done some testing, make sure they work, and they function. I've just got to install them. So I've got some cameras up. I've only got about half of what I had before, but all the important areas are covered. The outside's covered. I've actually got 2 separate systems. I've got a system on the house and a system on the garage, and they're all completely battery backed up and everything, so they last for ages. Yeah. So that's all isolated and network accessible, and yeah. Anyway, Western Digital blue. Okay, I'll have to look at that. I haven't seen that, I don't think. Let's have a quick look. Go to my current favourite supplier for things like that. There's a place I used to go to which was really cheap and seemed okay, but they've gone out of business. I don't know how. They used to do really well. Interesting. Well, the blue series is supposed to be like the everyday computing. That's like a standard drive, from what I can see here. Yeah, it just says for everyday computing on this website I'm using. Of course, you got the black series, which is the server grade, which I've actually got some here. Where are we? The computer I'm using right now is one I purchased recently, and it actually came with a whole bunch of stuff in it. So this is one of them. It came with 3 of these drives in it, 2 terabyte Western Digital Blacks. So these are good drives. What year are these? 2010 is the date on these drives, but they still seem fine. Nothing wrong with them. Red series, yeah, I think red was the Raid was it? Yeah, I think Raid was the Raid series, wasn't it? Hold on. Because I don't know. I don't know why they have to give them colours. Let's give it a bloody name, you know, instead of saying, you know. Yeah, so the red is the one that's designed for the RAID system. That's right. Yeah, for NAS storage systems. That's right. So that's what I'd have in my RAID as well. Is a bit of red series. Yeah, I mean the blue drives they're just standard computing drives, so they're just like a standard drive. There's nothing special about them. Which is why I'm surprised it's being used for videos, because I thought that would kill them fairly quickly. You know, they're not really designed for that heavy workload. Whereas the black series is like the next up. It's like enterprise drives, you know, heavy duty, high usage drives, and pretty fast. I think. Well, what specs on those things? I can't remember now. I have to keep looking this stuff up because I'm not really like a computer geek, really. Black series. This is maximum performance for power computing. Yeah, well, it's like, it's like a heavy duty drive anyway. It's like 7,200 revs or something. Is that right? Yeah. Yeah, 7,200 RPM, so slightly faster access. But yeah, it's interesting. So the purple one, which I found the other day when I was browsing around, those are the ones that's supposed to be for DVRs and network video recorders and stuff like that, because it's the right performance. But they're more expensive, of course. Oh yeah. I don't actually know what the drive specs actually are. I haven't really done comparisons as such. I've just sort of seen them and thought, oh yeah, you know, I'll just buy a drive which is specified for that purpose, just for simplicity. I don't analyse the performance, and like I chuck a drive in. If it works, it works. I'm not overly worried about it as long as it's kind of right. I mean, in my NVR right now, which is doing a new camera system, that's a standard hard drive. Okay, so that's because that's what I had laying around. I had a spare 1 terabyte hard drive. It's only a 2.5 inch form factor, so it's like the smaller form factor. So I didn't have many options there. I had a drive laying around, so I chucked it in. So it's even a used drive, and so far it's been fine. That's been running for about a month or two now. About a month I've had that running now, that system, and so far it hasn't faltered. It's been absolutely fine, so it seems okay. But I did purchase another drive here. It's this one here. It's a Seagate Barracuda, 2 terabyte. I decided to get a drive to have one ready for when it does fail. I just like to keep stuff around like that. And I've closed the window now. Hold on, let's find that again. What did I say this one's supposed to be suitable for? I think it was supposed to be suitable for this. Seagate. They're all called Barracuda these days, aren't they? Let's try and find a thing. If I can find a drive, I'll tell you more about it. Yeah, I'm not sure if this is supposed to be for DVRs or whatever. I think I wasn't too worried about it. I think I thought I'll chuck it in, and if it fails, I'll replace it again. Yeah, this one here was 150 New Zealand. So that's 5,400 revs. So I mean, it doesn't need to turn that fast. It's only a small amount of data, but it's just constantly going. It may be fast. I don't know. It's got a 128 megabyte cache on it. So yeah, it's probably over what it's going to be used for. But I'm assuming I'm going to use it for that. I may not even put it on there. But the system I've got can support 16 cameras. So I've got gigabit Ethernet right through the whole place. PoE powered, you know, the whole lot. So it's all the best you can get really, apart from going to gigabit. 10 gigabit Ethernet, which is like the next step up. Why is my stream saying it's offline? I hope it's not offline. Let's start again. I don't know. I don't know if it's playing it up for you or not, but right, I've been talking now for over 2 hours, and I could use a drink and I could use some lunch because my stomach keeps on growling. So I'm going to call it a day, and if I can find something else to talk about tomorrow, I might do another live stream. We'll see how we go. But so thanks everyone for joining me, and thanks for the chat, Sonia. And I'll catch you later on, and hopefully people find it a bit interesting. I don't know. Maybe I will. Maybe I won't. But it could have been gamers drives. Okay. Okay. Well, thanks everyone. Did it go off a bit? Yeah, I thought it might do. Yeah, it's struggling now. So I'll catch you later. Thanks everyone for watching, tuning in, and having a look. And if you missed the project, but go back to the beginning. Catch you later.